wheels of the wonder. Before I could even start talking about, before I could even start bombarding all of you amazing people out there with core engineering concepts and things like that, I would just like to tell you one thing. You guys are amazing. Because this is something which is required to start a specific talk, and I want all of you guys to be with me so that, it gets better for me. That's the whole point of it. So, wheels of the wonder. It's about automotive cybersecurity. It's about hardware hacking when it comes to cars. It's about hacking into cars and things related to automotive industry. How many of you guys have heard about hardware hacking or car hacking? Woo, that's a lot of people. So my talk is merely going to be focused on one single component of vehicles. And that component, which I'm going to disclose soon, is not the very common type of vulnerability type of thing, because when car hacking was first introduced to the public world, people used to focus much more on the CAN side and not the other components. And I mean, that's completely fine, because that's how the industry evolves. That's how you actually get started with doing something. I mean, and develop on it over a little bit period of time. So that's all with the first slide. I hope you like the colors. So we're going to discuss about the structure of the car. We're going to discuss about the attack surface. We're going to discuss about the most important thing, which is abuse techniques. And we're going to conclude that a little bit. I mean, honestly, in security, you can't really conclude on a one specific point, because if you sort of come up with breakage of some sort of an encryption, or if a company is claiming that my product cannot be hacked, then you know the answer, right? So that's the reason why it's pretty hard to sort of conclude that thing on some specific onto the real public. So we're going to discuss about the electronics of the car. We're going to discuss about the mechanics, the engine control unit and things like that. Not going to go much in depth into it, but still. We're going to discuss about the radio communication. That is one of the core part of this talk. And we're going to discuss about sensors. So here are the vehicle attack vectors. I mean, if you looked at a car back in 2010, you wouldn't be able to figure out with these many components. Of course, that's because the vehicle attack vectors actually are evolving around with time. So when there is one specific single component which is being introduced, for example, a Bluetooth. If Bluetooth is being introduced, then at that point, the hackers and the security researchers out there try to impose their concentration onto that specific single protocol or new feature. Because developers say that it's a bug. Because security researchers say that it's a bug, and developers say that it's a feature. So there is one problem when it comes to doing a pen test of this vehicles in general. That is the component which I said, the telematics control unit is often ignored. Now the job of a telematics control unit is to become like a master of all of the engine control units which are placed inside the car. So it will have different types of CAN messages, maybe some different kinds of communication protocols, and some talking between one component to other is always going on between these. And as a master ECU, TCU, the telematics control unit will be focused on this. The exploitation of telematics control unit will be focused on this talk. So that's why car hacking. Because if you are if you are not focusing our attention on the TCU, then that's what lead to car hacking. So we will be mostly focusing on telematics control unit attacks in this whole talk. That's gonna be the most talked about thing in the whole talk itself. So also, if I'm talking about hacking into a TCU, I'm talking about the exploitations and the hacks which are actually taking place to a specific vehicle out there. So don't take it the other way that he is just talking about a single car component, because it applies to the whole vehicle itself. Make sure you don't make that mistake. So, but before that, I mean, this guy is speaking, coming all of a sudden, talking about the telematics control unit. But who the hell is this guy? I mean, come on, that's how talks are to be designed, because first you should introduce yourself. I don't know, but I did not follow this approach. So who am I? Ladies and gentlemen, my name is Hrishikesh Somchatwar. I am a master student at Eurocom, and I am formally known as the storytelling hacker on Twitter. I am the best-selling author on Amazon. The name of my book is Hacking the Physical World. It's a light read. It's not a very highly technical core subject read. It's just for the beginners out there who want to get started in this journey. So I've been a speaker and trainer at various different conferences, such as B-Sides Delhi, Cocoon, B-Sides Ahmedabad, Hackfest Canada, DevCamp Romania 2019 and 2023, and a bunch of others, which I do. So I have a podcast which is available on Apple Podcasts, Spotify, Google Podcasts, and a bunch of others. The name is Storytelling Hacker. So I review research papers there. I give my perspective when it comes to hacking into things, and mostly it is related to hardware hacking and things like that, most on the physical layer and radio sometimes. Maybe I'll do a telco part. So that's it, enough self-promotion. So the attack surface. Now, I am not sure about how an individual does it, but I'm pretty sure that how the attack surface or some sort of a pen test has been carried out in the industry. It is generally by making a mind map. And this is how the mind map looks like. Now guys, just imagine that you guys have been given this different task by one dangerous manager or some weird manager who has been given the thing to give you tasks. So he's kind of weird, and he's tried to be much of a weirdo type of thing. Maybe he's trying to be a bit arrogant or something like that. And you are very new to this industry, and you directly see this image. What would the first emotion which would come to you guys' mind, to the mind of you people, or any person out there? Confusion. So, confusion, right? Me too, because see, when you are starting something with a single component and then building up over it, things get easier. But when you actually try to take all things at a time, consider if I tell you to read the slides of every single talk which has been given right now. Is that going to be easy? That's going to be confusing. So that's the point. I mean, it's going to be confusing. So, and I mean, whenever you are just starting things off, at that time, you are actually coming to know about some new sort of standards. And these are, I feel that these are some sort of trendy words which are being, I'm not claiming that standards are trendy, okay? Don't get me wrong. What I'm saying is, we are actually tend to focus on more on a technical approach. By technical, I don't mean the rebellious hacker kind of approach that you are given a task, just show that task to me. Just if you are able to do it, then your job is done. If you are able to not do it, then it's not done. We are actually going towards some sort of a world that standards are given more priority rather than something else. I mean, just consider a normal pen test approach. If we sort of do some sort of pen testing at that time, people are telling us to go through all of these standards out there instead of following your own approach. And that's the beauty. I mean, if you give up your own approach, guys, what is the point of being in InfoSec industry, in hacking community? Right? Because you guys are engineers, we are hackers. Our main job is to be more of a rebellious nature rather than following some industry specifics. So, correct me if I'm wrong, but this is my understanding. So that's the reason why I used a different approach. Anybody have seen this TV show? Please raise your hand. Okay, perfect. This is the audience which I'm going to love the most. So Suits, right? Everybody knows about Harvey Specter here, right? Yeah, perfect. So, I mean, I always come to this sort of mind block into while working, that what would happen if I sort of make a mistake? What would happen if somebody tries to dominate me, or some sort of a situation happens? And I sort of come to this sort of process of thinking, what would Harvey do? So this is some sort of a imaginative approach when it comes to doing a pen testing. And of course, you cannot tell the story to your manager, that is for sure. He's going to laugh just like you guys are laughing now, but on a different context. So what would Harvey do? Go all in. Because that is what we guys are doing every time. Whenever you guys or any pen tester is given a problem statement or a challenge, it's his job to complete it, because the reputation is online. I mean, consider if you are the new worker and you are actually given some set of tasks. You are actually given some sort of work and your reputation is on the line. Because if you mess it up, then the things would be quite different. But then you might not get a project or something like that would happen. That's why. So, enough of the philosophy thing, and here we go, technical stuff. The telematics control unit, this is going to be our target. So, as you can see, this beautiful TCU has a network and a GPS. So, this is just to show the image first. So, what do? You find out the interfaces first. The interfaces, okay. Interfaces are basically the features list. So, whatever the features are there of the specific component, these are going to be the ways or points which can be used to exploit this specific thing. Now, it has a telco chip, it has a GPS, and it has hardware, because it's a hardware tool, and radio. So these are the 4 interfaces which we are going to look at and we are going to focus on while hacking into this telematics control unit. So the telecom part. Anybody who is in telecom industry? Okay, there are some. Nice. A couple of people. So here's the flow graph. Now, consider, pardon me for my bad designing skills. Now, this, my friend, is a TCU. So this TCU, consider this as a car itself. And this telematics control unit is sending the data to cloud servers using this BTS, the base station. And it is sending the data to the cloud server and doing it back and forth. So it's like sending, receiving, and all of these things are happening over internet. Now, what we do is, we create a fake BTS. We create our own cell phone network and we try to exploit it. We try to exploit the telematics control unit in this approach. So, now, for that, you some sort of create fake BTS, you make fake cell phone networks, you create you trick the phones and you sort of make it to connect it with your own fake BTS. Now, in this approach, you use a software-defined radio, which is a USRP B210. That's what we used in our approach. And we used OpenBTS because you don't have to go through the technical specifications of doing a downgrade and then exploiting it, because if it's working on OpenBTS, then it's perfect. So, since we created our own fake BTS, we were able to connect that specific BTS also to our own phones. So if we are able to connect it to our phones, you can trick the iPhone. Since I connected it, you can start sending fake calls and texts to your phone as well. That's crazy, right? And of course, we had a lot of fun with it while doing this specific process. Ladies and gentlemen, I'm actually focusing much more on the setup side first, and then the exploitation side will be covered. So hold your horses. Okay. Yeah, so you can do a lot of things with it. Look at the screenshot out there. It's going to be like you can use any kind of random number when the device is connected to your fake BTS. You can send your bank, ask do some impersonification and ask for bank details, or hi Hrishikesh, you're hacked, or something like that. Or any kind of fraud can be done using this technique. So make sure that you don't do it for the bad purpose. So, since you created number of fake towers, and yeah, so you can see, guys, that this is this is the laptop which had my USRP B210, which has created a fake BTS, which has created a fake base station, and it had and here's a phone which was telling of all of the existing cell phone towers which are actually available on the wireless, on the frequency range. And you can see in the second one, this is the test PLM something. So that's the thing. So now once you are in, then once you are inside, once you are able to connect that device to your own fake BTS, at that time, you'll be able to see the IMEI, the MZ, and other important private information which cannot be leaked online. So you can do calls, you can send messages to anybody and things like that. Now consider this thing that you are sending your messages, some sort of messages to a specific car, and it is receiving some sort of signal. It is receiving those kind of text messages, and people would go crazy behind it. So now you do the Wireshark analysis of whatever the data which has been transmitted back and forth to the to the TCU, to the telematics control unit. So you can see that the protocol is GSM tap, and you can do the analysis. You can have the PCAP. This is an example of an MITM, which is a man-in-the-middle attack using telco networks. And you can check for interfaces. You can find FOTA credentials, I mean firmware over the updates. Consider if the vendor of the telematics control unit of the car actually pushes a firmware over the air update. Once you do that, you can sniff into that link, you can download that link, just do a wget and have access to all the web portals. So that's serious, right? Now, so the telco part, my favorite part, is done. Now the second favorite parts come into picture, which is hardware. So before that, I mean, how many of you guys know about the IoT router hacking thing? Just raise your hand. IoT hardware hacking, stuff like that. Okay. So whenever you are actually opening up an IoT device, at that time, Some people have brought up a tampering device protection into this particular system. So whenever you open up the device, the entire firmware gets burnt up, and because of those sensors out there. So you need to find what are those sensors which are actually available inside the TCU. And for that, you can't literally open up the device. You are given a device, you cannot open it, and you need to figure out if it has a tampering device protection. So what do? You take an X-ray of it. So we did a lot of social engineering to get the X-rays done. And it was very scary, very scary, as in we were pretty scared. If we sort of use the device, if it sorts of messes up with the device, then it might even affect the entire medical X-ray scanner, and it might lead to some havocs. So yeah. So here is the telemetry, and we figured out that it had no it had no tampering protection. So that's the reason why we opened it up. So we opened up the device. Ta-da! So you guys can see that there's a telco chip. You can see this is the antenna. We have a couple of UARTs. Maybe one of them is UART, because I have not, remember, so far I have not tried to do the logic analyzer stuff. So still trying to figure out. But you guys can see that there's also SPI chip, and the SoC, the system on chip, it is actually behind it. So these are the communication protocols, and this is the actual baseband chip which was being used to exploit it. I cannot disclose the vendor name, but I'm not going to say anything because I'm on record. And here's the antenna for that. And when you just turn around the device, you see the SoC, the system on chip. And the funny part is, along with the baseband chip, there's also a plastic SIM there. Since there's a plastic SIM, we remove that plastic SIM, we add our own plastic SIM, and we try to connect it to the internet, and then we'll just do the Wireshark analysis, which I just showed right now. Now, since it has the UART connector and all of the debugging pins out there, I use JTagulator. So when I use a JTagulator, I try to figure out that what are the pinouts, and basically just try to get a route and maybe drink beer after that, because that's what you do. You get a route, you drink the beer. So now the hardware's JTagulator is here. Now we sort of try to sniff in, and then we try to get some data over the serial, and we get some gibberish information. So what do? We did since it was using a custom baud rate. Now since it was using a custom baud rate, we did a UART pass-through. So this feature is actually available on the JTagulator. So I mean, like, you can also try to brute force your own different kind of baud rates, and then try to figure out if this which kind of baud rate is supported and things like that. And also do UART brute force, UART pass-through. You do a pinout scan, and that's it. So now you're done with the two parts. You're remaining with the last, or maybe the second last one. GPS part. Now this was pretty straightforward for us, guys. For GPS, we did not have to do a lot of hardware hacking, or like try to opening up device or analyze data sheets or something like that. It wasn't required for that time. So, however, even though the process was pretty straightforward, it doesn't look like it was pretty straightforward, right? The reason being, it is because the setup is there, but the setup needs some sort of signals from the GPS satellites. So if it needs the signals from the GPS satellites, it has to be connected to the internet, and it has to be near the window side. This is window, guys. Like, this is a normal window. And we were able to get the UART coordinates on the serial monitor using the custom baud rate which we figured out back then. I mean, like the custom baud rate which was being used by doing a UART pass-through. And we were able to get the the coordinates of the specific UART ports. So that is the thing. So it was a TTL data on UART. It was transistor to transistor logic converter was used for it. And same thing, we used, like since it was a custom baud rate, so we figured out the baud rate and then we sort of figured it out. And then we used a JTagulator. Now, the setup for GPS was that we just used a HackRF. We created a simulated environment with the HackRF. We disconnected the device from the GPS, then we reconnected it, and we were able to get the data of our own simulated GPS. Now, if it's our own simulated GPS, then you can give the location of even Antarctica of your car while doing this. So we did some jamming. We jammed into the GPS signals. We spoofed into showing some different locations were shown, because just to demonstrate that this attack can be done. And we simulated this, like since the GPS simulation was taking place in this context. So the telematics control unit plays a major role in car hacking. We cannot ignore that sort of mechanism, and we cannot ignore the telematics control unit, because that is one of the most important key components. Companies should focus more on this specific component, and they should find some sort of security mechanism for the same. The mitigations and security. So the thing is that since it has a different type of, since a vehicle has different types of component in it, you need to make sure that you go in depth with all of those components. Maybe this was being ignored, and that is the reason why we were able to find so many vulnerabilities, because we just decided to go all in. And one must know that the severity of these devices are, these flaws are really dangerous. And I mean, consider if you have a vehicle and it is showing the location of Antarctica. Consider if you are driving a vehicle and someone else is sort of getting the data of the cloud servers on his computer. He can often try to open up the camera, or even he can sort of apply some brakes, or maybe just do accidents with it, because this has happened in the past. So this is something which has to be taken care. And that's it from me. And this is how Harvey looks like in a car.